Hello again. Second video for section 7.6, talking about sine and cosine ratios. So, some examples. The directions say use a cosine or a sine ratio to find the value of each variable, round decimals to the nearest tenth. All right, so again, these trig functions. We use the trig function of an angle, and it's going to be one of the acute angles. So in this first example, it's going to be that 57 degrees. Now, which trig function do you use? Well, you got sine, you got cosine, you got tangent. Which one you use, it depends on what side you do know and what side you're trying to find. So let's start by finding A. So with that 57 degrees, we know the opposite side. We are looking for the adjacent side. So the only trig function that dealt with opposite and adjacent, that was tangent. Okay, this is the thought process. So the tangent of 57 degrees equals 14, the opposite over the adjacent A. Okay, so we could use the tangent ratio and solve for A. Now, it really doesn't follow directions. It says use sine or cosine. So we could use it. It works. It will work. It'll give us the right answer. But let's follow the directions. So in order to use sine or cosine, we can't find A first. So now let's find B. All right, we still know our 57 degrees. The 14 is still the opposite. B is the hypotenuse. So the trig function that related the opposite leg to the hypotenuse, that was our sine function. So it still works the same way. Sine of 57 degrees. The sine ratio is the opposite, which is 14, over the hypotenuse, which is B. All right, so to solve for B, just like we did in the second video with the tangents, we're going to multiply both sides by B. We can't solve for a variable when it's in the denominator. So by multiplying both sides by that, it gets it out of that denominator. Now we got to divide by the sine of 57 degrees. Those B's are gone, so we're just left with those sine of 57's cancel out. B equals 14 divided by whatever the sine of 57 degrees is. That's where the calculator comes in. Turn it on. I'm going to double check. Still in degrees. Always check that. 14 divided by, we hit the sine button, which is 2 above the 7 of 57 degrees. Hit enter. Side B is, and it said round to the nearest tenth, so we got 16.7. There's our length for B. Okay. Now, we've got some options here. Need a little bit more space. We've got some options to solve for A. Now that we know B, we could do Pythagorean theorem. We could also keep on using our trig function. Now, you've had lots of practice with Pythagorean theorem. You should be experts at it by now. Let's get some practice with these trig ratios. To solve for side A, now that we know the hypotenuse, let's use the cosine function. All right? Side A is still the adjacent side, but now we know the hypotenuse. So the cosine of 57 degrees equals the adjacent side A over the hypotenuse, we said was 16.7. So to solve for A, multiply both sides by 16.7. So I'm just going to, on my calculator, I've already got that 16.7 not rounded, so my calculator is going to give me a better answer. So I'm just going to hit the multiplication button. It's going to take that last answer, multiply by cosine of 57, hit enter. A is, to the nearest tenth, 9.1. Okay, if you use the 16.7, you cut off a lot of decimals. You're probably going to get a little bit of a different answer. Maybe it rounded to 9.0, maybe it rounded to 9.2. You should be in the ballpark. Try to use more decimals until you get to your final answer. All right, there's A and B, those two variables. All right, excuse me, for example number 14, we'll just set it up. We don't need to go through the solving because I got some more examples I want to go through, some different ones. But again, here's our acute angle that we're dealing with. Side 17, this is our opposite side. D is our hypotenuse. So relating those three things, the angle to the opposite hypotenuse, that is our sine function. Sine of the angle equals the opposite side over the hypotenuse, which is D. So we could solve for D. To get side C, that's the adjacent side. Now, we know the opposite side. We're looking for the adjacent side. Again, the directions don't say use tangent, but it's too easy. It's that ratio. We're given the 17. We know it's accurate. So tangent of 41 equals opposite 17 over adjacent C. If you didn't want to not follow the directions, you would have to do cosine of 41, which would equal C, the adjacent side, over the hypotenuse, which is D. You solve for D in that first step. Okay, so you could have used that answer. That's how you do these. All right. Similar examples. Again, let's just set them up. To find the value of T, that is the opposite side. The key thing here is just identifying. I'm dealing with a 51-degree angle. It's there. That makes T the opposite side. That makes U the adjacent side. Across from the right angle is always the hypotenuse. So to find T, opposite and hypotenuse, that is our sine function. So the sine of the angle, 51, equals the opposite, which is T over the hypotenuse, which is 32. So to solve for T, multiply both sides by 32. Remember, nothing touches that angle measurement. Nothing goes inside a trig function. From the outside, it does not go inside. So we got 30, whoops, see, hang on. We got 32, I messed that up. 32, there we go, times the sine of 51, enter. Side T is, if we round these to the nearest tenth again, we got 24.9. There's our value of T. To find U, that's the adjacent. We still know the hypotenuse. That's our trig ratio, or sorry, our cosine ratio. Cosine of 51 equals the adjacent U over hypotenuse 32. Again, to solve for U, we're going to multiply by 32. So side U equals 32 times the cosine of 51 degrees. Side U is 20.1, rounded to the nearest tenth. All right. Number 17, you can try that on your own. If you're not sure if you do it right, ask me in class. But these are the trig functions. This is how you do this stuff. It's a matter of identifying your opposite and adjacent sides, identifying the hypotenuse, which side do you know, and which side are you looking for. And that tells you, oh, I need to use this trig ratio because it's this side over that side. And then it just becomes a matter of solving. So that is it for section 7.6. Have a good day.